Before we start to learn how to repair and maintain refrigerators, what's important is we need to understand this drawing. This is a very, very important drawing to understand in terms of how refrigeration works. If we have a look at the stages, you've got 4 stages. You've got the first stage, second stage, third stage, and fourth stage. Let's start with the components. I have a compressor, a condenser, capillary tube, and an evaporator. You'll have a look at the condensers. Sometimes you'll have a condenser fan, and its purpose is to bring cold air and expel warm air. If I look at my evaporator, sometimes there will be a evaporator fan which circulates the warm air. As it moves into the evaporator, it starts to freeze up and the hot moves to cold. From here, the refrigerant collects this warm and it expels it out the system. As it comes out of the evaporator, it's now come into a cold gas and goes into my compressor back to be recycled, and the cycle continues. Going through the stages again, for this to transform into a hot liquid, it has to come out and cool down, comes back into the capillary tube, gets expelled. Stage 3 draws out the warm and the cycle repeats. If I demonstrate here, we have our superheats here, and I have my subcooled liquid and a gas liquid mix. What I want to explain is I want to split this up into 4, and let's start with quadrant number 1. As I mentioned, because there's high pressure, we have high heat, and the refrigerant is in a gaseous state. It moves to the condenser, where it starts to cool down, and it moves to my second stage as a subcooled liquid, still high pressure, relatively warm, and it goes into my capillary tube. This is, as I mentioned, is a hot liquid, so the idea is it's going to transform into a cold liquid as it gets jetted out of the capillary tube. This is now going to be a mix of gas and liquid. Now this becomes your low pressure. From here, the refrigerant moves to my evaporator, and it starts to, you'll see it usually ices up, or it has some frosting inside the evaporator, and it moves back to the compressor as a cold gas, and this is your superheated cold gas. Now, the idea of a refrigerator is to remove heat from whatever items inside your refrigerator, and the purpose of your condenser is to draw cold air and expel warm air. This is your basic principle of refrigeration. By following this is any refrigeration unit that uses a normal standard refrigerant. The cycle is exactly the same, whether it's a ice machine, a refrigerator unit, a freezer, even a car air conditioner, in fact even a normal standard air conditioner. The principles will be the same. You might have 1 or 2 components that are different, but we'll go through that throughout the course. Here we have a standard domestic refrigerator. Domestic because it uses a capillary tube. Only difference between this and a home fridge, for instance, is you've got a different type of condenser. This one uses a fan to cool the refrigerant, whereas your domestic just has a fixed condensing unit at the back of the fridge or inside the fridge. Just to go over the components, we've got a compressor. In one of the videos I explained how the inner workings of the compressor. So there's a rule to remember: thick, low pressure, and right at the bottom here is a thin pipe. That's going to be our high pressure. So if we follow the cycle, compressor compresses the gas, goes to the high, comes out the high side, gets cooled off in the condenser, comes out into the filter dryer, capillary tube, into the evaporator, which I'll show inside a little later, and it returns via this pipe, because it's a thick one, back into our compressor. The other components, this is your Schrader valve. Right over here we've got our capacitor, our thermostat. Obviously with different fridges you have different locations for your thermostat. If we look inside the little fridge, we'll see here is our evaporator. This little configuration here is only for demonstration purposes for the test fridge. This is just to show to indicate the ice flow on the actual evaporator. But if I have a look here, you've got your capillary tube, which is coming from the filter dryer, and it is going straight into the evaporator by this little modification. So from here, the capillary tube comes through here into the evaporator, starts freezing down, runs through the actual evaporator, comes back and goes into this section here, which is your accumulator. This I'll explain in the theory, and as it comes out of the accumulator side, it goes straight to the compressor via the thick pipe. If we do have a look here, I'm going to try my best to tilt this up. You usually wrap your capillary tube around your suction line, and this creates a heat exchange between the two pressures. Important to remember, if you do have a evaporator and you're not quite sure which side is your suction, which is your in and which is your out, always remember that your accumulator side has to be on your outside. So in other words, the refrigerant will come in here, go through the evaporator, come to the accumulator, and be expelled by this tube, just like that. Back to our drawing board, I'm going to explain how the mini bar fridge works. We've got a compressor, condenser, our filter, our capillary tube, our evaporator, our accumulator, and our suction return line. And here is where we have our heat exchange, where the capillary tube is wrapped around the suction line. The compressor purpose is to compress the refrigerant to the condenser where it's going to be cooled. This specific one has a little fan, runs to my filter dryer, and that's going to remove moisture and any small debris. To my metering device, which is the capillary tube, the refrigerant gets expelled into the evaporator, and as it comes out it goes to the accumulator to expand the gas further so that we don't get liquid back into the compressor. So by the time it comes out the accumulator, we've got more of a gaseous state. As the suction line returns, my heat exchange expands the gas further into a gas, and it returns back into the compressor. The reason why we have the accumulator and the heat exchange is so that we only have gas returning back into the compressor, because at these stages here it's still a liquid, and by the time it comes out of the evaporator we might still have some liquid, which we want to minimize because the liquid will damage the pistons and the valves inside the compressor. Here is another domestic refrigerator. The only thing that's different compared to the last fridge I showed you is the condenser. If we look at everything else, we've got the compressor, thick pipe, thin pipe. So we know that this is our suction, this is a high pressure side, and this is our suction pipe here. Always important to remember which pipe is which. The thin is always going to be the high pressure side, the thick will always be the low pressure side. Over here, you've got a drip pan. All this is going to do is, when the ice builds up inside the fridge and it goes into defrost mode, there's a little pipe that comes, drops the water in here, and the heat of the compressor will evaporate this water so we don't have a puddle on the floor. Follow the pipes. High pressure side comes out, goes into the condenser, and it returns. You do get some fridges where you seem to see two pipes going into the fridge. That is just a door heater, but the principles are going to be the same. As the gas comes, the high pressure side comes back, it goes into the capillary tube via the filter, and this goes straight into, yes, if you follow the capillary tube, goes straight into the evaporator unit. But if you have a look, the principles are the same. Only difference is I can't show you the evaporator, which is it's built inside the actual fridge unit. Here is the domestic refrigerator. We've got the freezer compartment and the fridge compartment. Back to principles: compressor, condenser. These are those door heaters which I was explaining in the other video, where you see the two pipes disappear into the refrigeration unit. The filter dryer, capillary tube, freezer evaporator, and the fridge evaporator to accumulator, and the pipe, the refrigerant returns. Following this, same principles, nothing's changed. I put my high pressure goes through the condenser, gets cooled down. This is an interesting part. So you'll see these two pipes go into the refrigeration box, and it's just wrapped around the actual door of the refrigerator. Usually these are prone to leaking. What you can do, because our climate is allowing it, is if you do have a leak in your door system, is you can cut these pipes there, and you can create a joint, which this is going to be at the back of that compartment which you saw. From here it comes out and it goes to my filter dryer, capillary tube. There's my heat exchange, and it runs through the freezer compartment first, and then it runs into the fridge compartment, my accumulator, and returns the cycle. If you have a look here, the evaporators are split, one for the freezer compartment and one for the fridge compartment. Reason: because we want the most cool or the coldest part coming to the freezer first to ice that up. Any remnants will come to our fridge compartment and return to the actual system. This is an example of a very dirty fridge. This just came from one of the sites, so that's why it's a little bit dirty. This is a Coke fridge, and I just want to show the principles again. So we've got our compressor. This is your electrical connections. Here's our Schrader valve. If we follow the line again, we've got our pipe coming out, which is thin, and if we look here, this is our return because it's thick. So from here, the high pressure comes out, goes into this. This is to evaporate water, pretty much similar to the other fridge. I've got a pipe that goes inside here, so any water that's coming from the evaporator will come into this tray, and because this is going to be relatively warm, it'll evaporate the water so we don't have a puddle on the floor. If I follow this pipe, as the high pressure comes through, it's pretty warm, comes into this element here, winds itself around, comes back up into the condenser, and comes out via this side. I don't know if you can see, but you've got your filter, and here's a capillary tube that gets wound up, and it goes straight into the evaporator. The only difference with this is we've got a bigger capillary tube, and we'll have a bigger filter. Your condenser here is fan cooled, and again, the principles don't change very much. Just a quick one. Usually these fridges are prone to leaking, and the leaking will be from this element here, because it's constantly submerged in water. You've got a lot of dirt inside here, and with the vibration it can actually act like a sandpaper to slowly erode these copper pipes. So if you do have a leak on these beverage fridges, it will usually be from this element. And to replace this element, all you do is simply cut it off and bend a new pipe with your pipe bender. Now if we follow the capillary tube, all it's doing is it's coming into this evaporator. On your beverage fridge, this will have a fan over here, and the hot air will move through the evaporator. Going back to the capillary tube, here it is over here, runs through the actual evaporator, comes back, and here is your accumulator, which goes straight back to the compressor. If you look over here, this is the example. Okay, this broke off, so we'll have to repair it, but pretty much any ice that gets built up inside here and it melts, it'll run down this tube into that coil at the bottom by the compressor, which will evaporate the water so we don't have a puddle on the floor. Back to the drawing board. Here is the configuration of our Coke fridge. Have a look. Compressor, condenser. This is the drip tray heater, filter, capillary tube, evaporator, and accumulator. Once again, the principles haven't changed. Only thing that's changed is that we have a condenser with a fan, we've got an evaporator with a fan, and we've got this drip tray heater. So what happens with this is our high pressure comes out, it's high heat, gets cooled down. This is going to be relatively warm, and all that's going to happen is any moisture or water coming from our evaporator will fall into this tray, and this will heat it up because of the evaporation effect. This is relatively warm, so it'll just evaporate whatever water falls inside from the evaporator. There will be that little pipe that I explained earlier. Filter, capillary tube, heat exchange, evaporator, fan, accumulator, and the cycle continues. If you notice, compared to the other two videos or the other two drawings, nothing has changed in terms of the principles of refrigeration.